All right, so at the end of class yesterday, we just talked about two properties of logs, right? Remember that? And in both of those cases, we talked about what the bases were the same, that they would simplify. And one of those cases where if we had a base, some number, and it was raised to kind of a weird exponent. If it was raised to an exponent that was a log that had the same base. And if that happened, then it would just simplify to x. That basically these bases being the same would undo each other. And we would be left with just an x. And then the other property was if we had a log that had a base, and then we had that same number, same letter that was raised to a power, we said that that also simplified to just an x. So that's where we ended class yesterday, was just talking about these two properties of logs. And I said we would start class today by practicing some problems like that. So on page 490, I'd like to give you guys some time to work on page 490. We're going to look at problems 48 to 55. And the goal each time, most of them have the bases that match up already, but if they don't, you want to make sure that the bases match up. And if they don't already, then maybe you could change, not necessarily change a number, but express it in a way where the bases do match up. There's a couple of those that you could work on expressing a number in a way that the bases match up. So I'm going to give you guys some time to work on 48 to 55, maybe just 4 or 5 minutes. And then we're going to go over those answers. All right, let's go over these answers. Now, starting with 48, 49, 50, 51 should have been pretty easy because they look like one of these two examples every time except b is some number, right? So every one of those simplify to b, or to x. Every one of those, the answer is just an x. So it's not until you get to problem 52 do we get anything really interesting. 52 is a log with base 4, but it says 16. And 16 is not the same thing as 4. So we can't just simplify it and say it's x. But we can express 16 as a number that has a base of 4. Right? 4 squared. So when we rewrite it, instead of 16, we're going to write 4 squared. The x is still a part of the situation, though, isn't it? Okay, so now that's 4 to the 2x. Now our bases do match up, and so it simplifies to 2x. 53 is back to the bases matching already. Simplifies to x. Easy schmeezy. Tell me about 54. It says log 100 to the x, right? And it doesn't even say what base it is. So what did we talk about before about the logs that don't have a base? What is the base? Yeah. Base isn't 1. No? The base is 10. This is what we call the common log. So it's so common that they do not bother to even write in what that base is. And that's what your calculators use. If you look at your log button on your calculator, they don't bother to put in a base, do they? They say log. It's the common log. It's understood that that is a log with base 10. So it's kind of like when you see a square root sign, they don't put an index number of a 2, but you know that there's an index number of a 2 in there. But it's so common that they don't have to write it in. Now, if it's something other than a 2, then they write it in. Does that make sense? So this is what we call a common log. Now, is there a way to express 100 so that it has a base of 10? Yeah, that looks just like 52, doesn't it? So that's 10 squared. So that's now 2x. Now our bases match up. Simplifies to 2x. What about 55? This base was 20, and then this was 8,000 to the x. So, can we make 8,000 have a base of 20? Okay, 20 to what power? To the power of 3? Did anyone check it on their calculator to make sure? Good, you should be, right? You should check that. But you should also look at the 2 and the 8 and see that relationship, right? 2 to the third power is 8. And then you also look at the number of zeros. There's 1 0 in 20, and then there's 3 zeros in 8,000. So raising to the third power is going to be okay here. So we could rewrite this 20 to the third power, and then we have our x. So now our bases match up. It simplifies to 3x. We'll be using these two properties when we get into solving tomorrow afternoon and then into Monday. We'll use these two properties quite a bit in our solving. We're going to learn some more properties today to help us with these. But so we're going to come back to this skill when we get more into solving, right? Any questions? All right, cool.